Hey, so we're back with the robotics project. This time we're going to do some final wiring for the motors and get into some code to try and make controlling those motors a little bit more sensible. Last time, or since the last time we spoke, I wired up the battery to a little switch just to make it easier to turn the thing on and off, and then I brought it up around and forked it to two different wires. So now I can take my power the two motor controllers just from the battery source and switch it. Remember last time I mentioned that the motor controllers have a 5-volt regulator on them as well, so I can use that to power the Arduino. So with that in place, the first thing I wanted to do was add a little prototype board so I can do some wiring and hook up the power from one of the motor controllers anyway, just to power the prototype board. And then I hooked up some jumpers to the pulse width modulation. The problem that I've got is there's not enough digital IOs for each of the directional controls on the motor controller. So what I'm going to use here is a 7404 Hex Inverter, which has 6 devices on it. And basically what will happen is when I bring an input in, I'll just tie it to the Hex Inverter, so I'll get a high and a low, or a low and a high. I'm not worried about a high and a high, or a low and a low, because I can just drop the pulse width down. If you notice on that little chip, there's a little notch. That's how you know where pin 1 is. So we can just wire it up, add some voltage to it, and then start using all of my non-pulse width modulation pins on the Arduino. So I only need 4 as opposed to 8. That saves me a lot of I/O ports. And then we can get into some code. So this is a normal Sketchup, or a normal sketch, Arduino sketch. Start off just by setting up the serial port so I can get some debugging from this. And I'm just sort of getting a feel here for what I want the interface to look like. I started with a motor, but then I realized there's 2 motors per controller. So then I thought let's add a controller object for the front 2 motors and the back 2 motors, and then associate the motor objects with that, with a channel 1 or channel 2. So what we'll see here is we've got front left, front right, rear left, rear right motors. And I'm just trying to remember my C++. It's been a while. I've been doing a lot of Python lately. So there's a lot of syntax errors here, which I fix up later. But I'm just sort of getting my feet under me again. I had to remember, I should have written this down, but I was trying to remember what my pins were that I used for each of the things, so I just wired it up. So I had to keep poking around at the wires to see where I wired things in. Anyway, found them. So each controller gets an enable and a pulse width modulation for each channel, and then I just store that in the controller object. And the motor objects, which are linked to the controller objects, just pass in their channel, and the controller will do the right thing. So, for example, I've got this get enable method here, which uses the appropriate value, and the same thing for pulse width modulation. It'll either pick channel 1 or channel 2 depending on what you pass in. So then when I in the constructor here, I'll also just set up the pin modes. There's a little syntax error in there, not a syntax error, but a logical error, which I fix up later. I'll touch on that maybe afterwards. So now I can start to make some higher level methods like speed and direction. Instead of having to worry about pins and values, I can use higher level concepts. And then I can pass these same sort of operations down to motor. So operations like forward and reverse and that sort of stuff. So you see, if you get a call from forward or reverse on the motor, it just passes it into the controller with a channel on it to say, here, do this thing. Same thing with speed. So now this should just give me some, this should be just all 4 motors running in the forward direction at about half speed. And one of them is not. You see that front motor there, that front left motor is going in the wrong direction. So I've got something done wrong here. And it's not the motors to the motor controller, it's the logic, it's the Hex Inverter going up to the Arduino. So I reversed them, and I reversed the wrong one. So now the 2 front motors are going in reverse, and the 2 back ones are going forward like they should be. So I just got to flip everything around. So pull out the wires for the forward motor controller and reverse the logic. And now they're all going forward. Yay. So now I've got some basic motion going here, and now I can start to pretty up the code and make it even more usable. First thing I want to do is play around with the speed and individual motors. So what I'll do here is I'll just get all 4 motors going forward, and then one by one every second turn a motor into reverse direction. And you can see them flipping through here. One thing sort of odd is sometimes a motor will go and sometimes it won't go. We'll get into that next week. So now that I've got things sort of working, I introduce a robot object, which sort of wraps up all those controllers and all that stuff. So now when I want to operate this thing, I just talk to the robot object and say, go forward, go backwards, stop, here's your speed, whatever. So I pull out a lot of the individual motor operations out of setup and loop and move those up into the robot object. And see that speed 127? That'll come back to bite me later. So in this case now I'm just going to do 1 second forward, 1 second in reverse on the robot object instead, and just see how that works out. So that should just go forward and reverse. And then I'm also going to introduce a speed, so we'll ramp up the speed. We'll start at 0, and then we'll slowly ramp the speed up. And then we'll step the speed down. So as it hits the top speed, it'll start going in the reverse direction by steps of 10. This is sort of, there's a million different ways to do this, and I just did the first one possible. And also output to the serial port so I can see what's going on here. So this is sped up a little bit. And it works, but it's not starting slow and then going fast. So and see how that motor stopped then? That's going to come back. That's going to be a thing to fix. I realized I had a syntax in there. I had it hard coded at a certain speed. So now you can hear it. So just have a listen to this. You can hear the motor controllers whining as they're bringing up the speed until eventually they get enough duty cycle that the motor will turn. There we go. And you notice they don't all come on at the same time. Every motor needs a little bit more duty cycle to operate. Eventually, they get there and they all start moving. And then they'll also go in the reverse direction. See? They slowly stop when the duty cycle runs out. So that's going to be something that's going to be really annoying to control. We'll get into that next time. And they'll eventually all stop and you hear the motors whining. So, the code's in place, something to work from. I've got some basic wiring, and now we can get into finer motor control, actually get into some turning operations, and start looking at how to determine exactly how much we've moved with each motor. And that'll be next time. Thanks very much.